Okay, got an exciting day today. Going to do some fun stuff. But first we're going to start with a little bit of review. So I'm going to put a couple matrices up here. Then we're going to do some things with them. So again, it'd be great if you had your piece of paper out and you were keeping track of all of these review problems, because what great review this will be, in addition to our regular practice tests and all that. This will be good review. Okay, so I'm going to have to bump this down a little bit so you can see it better. All right, so here are our matrices. Now, here are the questions that we're going to answer. There are, let's see, 6 questions. All right, so we're going to do this. We're going to do this. And we're going to do this with matrix A. So we'll start with matrix A. We're going to do those things with matrix A. So this means find the inverse. And you recall from our work the other day, that's a 2-step process. And the first step is to find the determinant. So we'll go ahead and do this part down here, and then that will help us do that. Okay, so how do we find, oh, wait a minute. What's the rule for a determinant? If you're going to find a determinant, the matrix has to be square. This one has no determinant. And because it doesn't have a determinant, it cannot have an inverse, because the first step to finding the inverse is finding the determinant. So those are both can't do's. The matrix has to be square to do either one of these two things, and it's not. All right, we can do this. This says look at matrix A and find the entry that is in the first row, second column. So the first row, second column, that entry is a 2. Done. Okay? Now, let's answer the exact same questions with matrix B. So in other words, we're going to find the determinant of B. We're going to find the inverse of B, and let's do B sub 2(1). Okay? So we'll go ahead and do this one first because it's so easy. So B sub 2(1) means go to matrix B and find the entry that is in the second row, first column. So that is -1. Second row, first column. That's this guy right here. Okay, now what about the determinant of B? Now remember, the rule for determinants is the matrix has to be square. Well, that is square. It's 2 rows and 2 columns. It is square. So we can find the determinant. So remember, you start right here, and we multiply 2 times 6. We multiply -1 times 3, and we subtract those. So it's 12 minus -3. So 12 minus -3, excuse me, gives me a determinant value of 15. The determinant is 15. Now, next we got to find the inverse. Now, luckily, we've already done step 1. Remember, finding the inverse is a 2-step process. The first step is find the determinant. The second step, remember, is find this new matrix. And remember how we find the new matrix. We take these 2 numbers, the 2 and the 6, and we switch them. So we're going to put 6 here and 2 here. Then, that's a +3, we make it a negative. That's a -1, we make it a positive. So these 2 numbers get switched. These 2 numbers, we change their signs. Then remember what we do? we take all of these numbers right here in this new matrix and we divide them all by the determinant. So we put them all over 15. And then we reduce, of course, any fraction that reduces. So our inverse, let's see, 2/5, -1/5, 1/15, and 2/15. There is your inverse. Now, if what I'm doing here is confusing to you, here's what you can do. You can go back to an earlier video and watch it again. If you've forgotten the steps, you can go back to the video that covered the steps and go through it. All right, we're going to do one more thing with these two matrices, and we got one more review problem, and then we'll be done. Or we'll be done with review. So we're going to multiply B times A. So we're going to multiply 2, 3, -1, 6 times A. Now, remember the rules for multiplication. You can't always multiply. So the first thing I probably want to do is check my dimensions. So this one is 2 by 2. This one is 2 by 3. Now remember, you can multiply as long as those match. Since they match, we're going to multiply, and our answer is going to be a 2 by 3. So it's going to have 2 rows and 3 columns, because that's what these outside dimensions tell me. So remember how we do that. Lost my red marker. We go ahead and label these spots if it helps you. This is first row, first column, first row, second column, first row, third column. Second row first, second row second, second row third. Remember, columns go across, rows go across, rows are the bleachers, columns go up and down. So row 1, column 1, row 1, column 2, row 1, column 3. Now, those labels tell me exactly what I am going to multiply by, or multiply in order to get those entries. So if I want this one right here, I'm going to multiply row 1 and column 1, row 1, column 1, row 1, column 1. So, squeeze it in down here. I take row 1, which is 2 and 3, and I multiply it by column 1, which is 1 and 5. So I multiply each set, so each pair, 2 times 1, 3 times 5, and I add those together. So 2 and 15, this number is a 17. Now, I'm going to do exactly the same thing here, only I have to use row 1 and column 2. So row 1 is still 2, 3, and column 2 is 2, -1. So I'm going to multiply those together. So 4 plus -3, so that number is a 1. And then we'll move over here. Row 1, column 3. So row 1 is still 2, 3. And column 3 is 3, 6. So now I'm going to multiply those together and add them. So 6 plus 18, so that gives me a 24. Now row 1 is done. So now I'm going to move on here to row 2. So now I'm going to be using -1, 6. And I'm going to take it times this column, and then this column, and then this column. And that's how I'm going to fill in those blanks. So I'm going to use -1, 6. And I'll start by multiplying it by 1, 5. Oops, 1, 5. And I'm going to add those together. So I have negative 1 plus 30, that's 29. Then I'll take my negative 1, 6 times 2, negative 1. That's my second column. And that's going to give me a negative 2 and a negative 6, so negative 8. And then I'm running out of room, so I'm going to do it up here. I still have my negative 1 and 6, but I'm going to multiply it by 3 and 6, which is the third column. I'm in the second row, and now the third column. So that's what, negative 3 and 36, 33? And there is your product. Good job. Okay, so that's multiplication. One more review problem. One more. And we're going to do the same problem twice using two different methods. So, we should look at this system of equations. 2x plus y equals 4, and 3x minus 2y equals negative 1. Now, I want you to solve this system using elimination. Okay? Review. We are reviewing. We're going to solve this system using elimination. So hopefully you have it done by now. Whoop, here comes Cat. Get out of the way. That's Lucy, in case you wondered. If I'm going to eliminate, I think it'd be easier to eliminate the y's. So I'm just going to multiply the top row by 2 all the way across. So 4x plus 2y equals 8. And 3x minus 2y equals negative 1. So notice I multiplied every number in the top row by 2 and left the bottom row alone. Now I'm going to add them straight down. So 7x equals 7. So x equals 1. Now that's pretty darn easy. You've been doing that since you were, what, 6th grade or something. You've been doing that a long time. But you're not done. If you now know that x is 1, then you have to plug that back into one of these equations. Guys, it doesn't matter. Pick one, whichever one looks easy. I think I'm going to go back and use the original one right here. Right here. So if I put in 1, I'm going to get 2 plus y equals 4, which means y equals 2. And then I will write my answer as the ordered pair 1, 2. Make sure when you write your answer that you have put x, y. They must go in that order to make sense. Okay, that was pretty easy. Now, I want you to hang on to that answer. You've got it on your paper there, because we're going to do the same problem now, the exact same problem, using Cramer's rule. Alrighty. So now we're going to use Cramer's rule. So do you remember what you do with Cramer's rule? You haven't done as much of this for sure. So it doesn't come as naturally as elimination. Remember, the first thing we do is make a determinant out of the coefficients. So right here, the x's and the y's, we're going to make a determinant. So 2, 1, 3, negative 2. So 2, 1, 3, negative 2, and then we're going to evaluate that. So that's negative 2, or actually, it's 2 times negative 2, and 3 times 1, and we subtract them. So it's 2, remember, start here. So it's 2 times negative 2 minus 3 times 1. So that actually is negative 7. Now remember, that negative 7 is important, because now when you solve for x and y, they're both going to be over -7. That becomes the denominator for your variables. All right. Now, how do we do the numerators? Do you remember this? This is where now we're going to use the 4 and the -1. We're going to cut that out. Cut it out. And for x, we're going to paste it right here on top of the x numbers. These are the x numbers right here, the 2 and the 3. We're going to paste 4, -1 in that spot. And then the y's stay the same. Notice I didn't move anything. I left the x's where they are. I left the y's where they are. I just pasted some new numbers in on top. Now, I'm going to do the same thing for y. Only I'm going to paste this on top of y. So I leave the x's where they are and paste 4, -1 in place. All right, now let's evaluate. So this, I'm going to multiply these two together. So that gives me -8. I'm going to multiply these two together. That gives me -1, and then I'm going to subtract them. So it's -8 minus -1. Well, that works out to be -7. Over -7, which gives me x equals 1. Down here, -2 minus 12. So 2 times -1, 3 times 4, subtract them. So -2 minus 12. Well, that's -14 over -7, which is 2. So x worked out to be 1, and y worked out to be 2. And if my feeble memory serves me, that is exactly what we got when we did it with elimination. Okay, enough of review. Get your notes out. Now we're going to do some word problems, and they're called linear programming. And you are going to have one on your test. So we'll practice as much as we can practice, but you guys, you're going to have to put some time and study on your own. You're going to have to watch and rewatch the videos. You're going to have to work through the problems as many times as you need to. Okay, so I am on section 7.5 of my notes. The page at the top says 47, and it's called 7.5. And it says, solve the following. Be sure to fill in the table, write a system of inequalities, and sketch. So, let me see if I can reproduce this table. By the way, if you do these problems lots of times and you need a template, I have put a template in Schoology that has this table. And the page looks just like this, only it just doesn't have the problem on it. So if you need more copies of that, you have them. You can make them. All right. Okay, so the first thing we're going to do is try to organize the data in the problem. So we're going to read it together. You're taking a test in which items of type A are worth 10 points and items of type B are worth 15 points. So right now, that tells me that the value of an A question is 10 and the value of a B question is 15. It takes 3 minutes for each item of type A and 6 minutes for each item of type B. So an A takes me 3 minutes, a B takes me 6 minutes. See what we're doing? We're just categorizing our data, trying to make it organized. Building this chart is not necessarily necessary to solving the problem. It just helps. Most people, it helps. The total time allowed is 60 minutes. So the total time is 60 minutes. You may not answer more than 16 questions. So the total number of questions can't be more than 16. The number of questions, the total is 16. The total time is 60. Assuming all of your answers are correct, how many of each type should you answer to get the best score? Now, do you remember when we were doing the tree diagrams and we always looked at the question to help us determine what order we would do our problems in, our trees? Well, this is kind of the same thing. I'm going to look at the question to determine what my variables are going to be. How many items of each type? So I'm going to let the number of A's be X and the number of B's be Y, because that's what I'm trying to figure out. I am trying to figure out an X and a Y. How many problems should I do on this test? Now, notice that everything is filled in except for this. Now, if you look at it, that would be the total value of the test. That's what you're looking for. You can't fill that one in. That one's going to stay empty until you get to the final answer. So we have put every number in the problem and our variables into the chart. So now we're ready to go. Now, you might be saying to yourself, what are these lines over here for? Well, I don't know how many of them I'm going to need. Sometimes I need all of them, sometimes I need more, sometimes I need less. That's where I'm going to put my equations, or actually my inequalities. So here's what I want you to think about for a second. It takes me 3 minutes for every X and 6 minutes for every Y, but I can't have more than 60 minutes. So doesn't it make sense to you that 3 X's plus 6 Y's have to be less than or equal to 60? You get 3 minutes for every X, 6 minutes for every Y, and you can't use more than 60 minutes. Now there's another inequality in there. Take a moment and I'll give you a hint. It says you may not answer more than 16 questions. Now what does that mean? You can't answer more than 16. That means that however many of A's you do and however many B's you do, added together, it has to be less than or equal to 16. So X plus Y has to be less than or equal to 16. Now, easy points implied in all of these problems, and there's probably one out there someplace where this isn't true, but in all the problems we do, we're implied that X and Y are both bigger than or equal to 0. Remember, X is how many questions you're doing of type A. Can that be negative? No. You can either do none or 1 or 2 or 3, but you can't do negative 18 questions. So X and Y are both going to be positive. And in fact, if you look at the grid that I have set up on your paper, notice that it is only quadrant 1. So I have my little grid board here, nifty little thing. Notice that I have put my axes here because I'm only in quadrant 1. There will be no negative numbers in this problem. No negative numbers at all. Now, I have one more blank to fill in. It says expression to maximize. Now, sometimes we minimize in these problems, so I don't want you to think it's always maximum, but you always do them the same way anyway. What am I trying to get the most of? What am I trying to maximize? I'm trying to maximize my score, just like you will on test day. So your score equals what? This is what you write in the blank. You're going to put this right there in that blank. Your score is calculated by 10x plus 15y. That's how we calculate the score on this particular test. Every X you get 10. Every Y you get 15. So now the problem is all set up. And what we are going to do now is sketch it on the grid. Now, I'm just going to give you a warning. Do not freak out. For Pete's sake, pause the video and make the grid bigger if you have to. I don't know what's going to happen, but I've only gone out to 12 and up to 16. If you need to extend these lines and make this thing bigger, go ahead. Or if you have other graph paper at home, feel free to use it. Whatever you do, don't freak out. Make the graph bigger so you have room for what you need. Okay, you can also always change the scale if you want to, and make each box worth 2 or something like that. Now I'm going to graph on this, okay? I'm going to graph on my little grid board. So the first equation I'm going to graph, by the way, I don't have to worry about graphing these two because my grid board has already done that. I am graphing only in the first quadrant, which means my X's are positive and my Y's are positive. So these two do not need graphed. Now I'm going to graph this one. Now I really, really need you to pay attention to what I'm doing here. Okay? Everybody paying attention? I am going to graph this using the intercepts. So here's what I mean. I am going to let X be 0. When I let X be 0, it says 6Y equals 60. Pretend that's an equals for a minute. So if I let X be 0, Y would have to be 10. So I'm going to plot the point 0, 10. Can you see it if I put it down there? So 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the point 0, 10. I'm going to go ahead and label it. All right. Now, I'm going to let Y be 0. So first I let X be 0, and I got Y as 10. Now I'm going to let Y be 0, and I get X as 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's the point 20, 0. I let X be 0 and figured out what Y was and plotted that point. Then I let Y be 0, figured out what X was, plotted that point. Now I'm going to connect those with as straight a line as I can draw. You have the advantage. You can use a straight edge or a ruler, get a nice straight line. Now notice that that is shaded. It's an inequality, so obviously it's shaded. And since it's less than, it's shaded underneath. So far, I am looking at this triangle right here that's shaded in. Now, can you guess what I'm going to do now? I'm going to sketch this one. And I'm going to do it exactly the same way. This is so much easier, guys, than trying to get Y by itself and using the slope. The problem with that is sometimes you're going to get bad numbers. It's just easier to use the intercepts. So if I let X be 0, what is Y? 16. So I'm going to plot the point 0, 16. So there's 10, 11, 12, 13, 14, 15, 16. So there's the point 0, 16. Now I'm going to let Y be 0. And X is also 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now I have plotted my two big black points. Can you see them there? 0, 16, and 16, 0. Now I'm going to connect those, again, with as straight a line as I can. And because that one is also a less than, I will be shading below the black line. Now, your shading's probably neater than mine, but your answer is going to be the part of the graph that is both red and black. In other words, it's shaded both times. So I'm going to outline that real quick. Do a heavy outline here so that you can see that area. So it looks like that. Does yours look like that? Okay. Now, what is the next step? Well, you notice I left some extra room there because now we have to figure out what all four of these big black points are. That one, and that one, and that one, and that one. Now, some of them are real easy. All right, so I'm going to erase this because I need more room. I am not going to erase this because we still need that. But here are my points, or here's my graph. So I know that this point right here, I'm sorry, this is hard to do. This point right here is 0, 10. And this point right here is, of course, 0, 0. And this point right here is 16, 0. I had those from my original picture labeled. So I'm going to write those down. I have 0, 10, 0, 0, and 16, 0. Now, there is one other point. This guy right here, he didn't happen when I did the original graphing. He happened because that's where the black line and the red line cross each other. Now, if you're really, really good, sometimes you can tell what that point is from your graph paper. I was kind of messy. I wasn't using a straight edge, so I'm not real confident that I know where that point is. So I think what I'm going to do is I'm going to find that point by taking these two equations and doing substitution or elimination with them. Because if I do substitution or elimination on these two equations right here, and I'm going to make these equals. When I do substitution or elimination on them, it will tell me where they cross. Now again, I'm telling you guys, if you can tell from your graph where it is, that's fine. But this is my grade. I really want to do well, so I'm going to actually work it out. Okay? So I'll go ahead and do it up here. I have 3x plus 6y equals 60. And then I think I'm going to multiply that one by -3. So it's -3x minus 3y equals -48. So I'm taking these two equations, which were my red one and my black one, on my graph. I want to know where they cross each other, so I'm doing substitution or elimination or Cramer's rule. I picked elimination because that's my favorite. So I left that equation alone, and I multiplied this one by -3. Please don't panic, you guys. Just make these equal signs. Just make them equals. We're looking where the lines cross. All right, so we have 3y equal to 12, so y is 4. So whatever that point is, the y coordinate is 4. How will I find the x coordinate? I do what I always do. I'll plug it back into one of these, probably this one to be the easiest. If y is 4, what will x be? 12? Now, that point right there then, on my graph, that fourth point, is 12, 4. So now I have 0, 10, 12, 4, 16, 0, and 0, 0 as the corners of my shaded area. Those are called the vertices. So you want to list them just like I did here. Those are the vertices. The answer to the question is going to be one of those points. So remember what your x and y stand for. Your x and y stand for the number of A's and the number of B's that you're doing. So that first point right here would mean you did no A's, but you did 10 B's. Well, now wait a second. What would my score be then if I did no A's but 10 B's? Well, remember you wrote that down. That's on your paper. You calculate your score by taking 10x plus 15y. So if x is 0 and y is 10, if you did this, the score on the test would be 150. 15 times 10. What if you did nothing? What if you did no questions? Well, then obviously your score is going to be 0. That, by the way, is not the maximum score. Obviously, that would be your minimum score. Don't do any questions, your score is 0. How about 16 and 0? Well, 16 and 0 would mean you had a score of 160. What about 12 and 4? Well, 12 and 4 would be 120 plus 60. That would be 180. Now remember, you're trying to maximize. So what are you going to do? How many questions are you going to do? You're going to do, I'm going to do 12 A's and, and 4 B's for a score of 180. So, like all good algebra students, we write our answer out in a complete sentence, and so you'll write something to that effect. And guess what? It's done. That problem is done. You're thinking, oh my golly, that was all one problem. Yes, it was. And here is the good news. We have another one. So turn the page. Now, this one I don't have the template set up for. So this would be a good time to go ahead and pause. Go to Schoology and find the linear programming template. And put it into Notability if you want, or print it if you can do that. Or you don't have to. I'm going to put it up here on my board. So we have it. And I have to write some inequalities over here. And we have to figure out what we are maximizing or minimizing. All right, now I have to read the problem before I can label anything. So I'm assuming that you're ready to go. So here we go. A farmer has a field of 70 acres in which he plants potatoes and corn. So in the last problem, we had question A and question B. Well, now we have potatoes and corn. The seed for potatoes costs $20 an acre. The seed for corn costs $60 an acre. And the farmer has $3,000 to spend on seed. The profit per acre of potatoes is $150. The profit for corn is $50. Find the optimal solution for the farmer. Okay, so The first thing that we're going to talk about is acres and seed. And I need one more row. Sorry about that. And that's going to be profit. This is going to be total over here. Now, what do I have in this problem? I have potatoes and corn. And the question ultimately is, how many acres of corn and potatoes should I plant? So I'm going to let potatoes be X and corn be Y. Because that's ultimately what I have to figure out. I want to make the most money that I can, but I need to figure out how many X's and Y's I'm going to plant. How many total acres do I have in the problem? It gives me a number. What does it say? We have 70 acres. Now, can I plant more than 70 acres? I have a farm field that's 70 acres. Can I plant more than that? No. So whatever X and Y are, added together, they must be less than or equal to 70. Can't plant more than 70 because that's all I have. How much does seed cost? For potatoes, it's $20. And for corn, it is $60. And how much money do I have to spend on seed? I have $3,000 to spend on seed. So whatever I spend on potatoes, plus whatever I spend on corn, has to be less than or equal to $3,000 because that's all the money that I have. Now, what's my profit? Potatoes is $150 and corn is $50. I do not know what my total profit is. That's what I'm trying to figure out. But I do know that I want to maximize my profit, like all good business people want to do, and that would be 150x plus 50y. Every x is worth 150 and every y is worth 50 in terms of profit. That's what I want to make as big as I possibly can. Now, what are the two gimmies here that I told you? You can always get easy points. You can always fill those in. We know that x has to be positive and y has to be positive. Kids, what does x stand for? Acres of corn, or acres of potatoes. X is acres of potatoes. Can you plant negative acres of potatoes? No. So X and Y have to both be positive. That will always be the case. Don't blow easy points. That is already taken into account on your grid because your grid is set up to only show quadrant 1. So on your paper, I would strongly recommend that you darken this, make that the y-axis, make this the x-axis, so that you don't get confused. You know you're looking at just quadrant 1. On the ones that I have done that for you, but this one isn't done, and that's fine because some of the ones we look at are out of different books. Darken this in, and now we're ready to go. All right, so we are going to graph this equation. Now, looking at the size of those numbers, I think I am going to let my scale be 10. So if I cover up X y is 70. But if my scale is 10, I'll plot it at 7. So in other words, that's going to look like this. 1, 2, 3, 4, 5, 6, 7. So there's the point, 0, 70. Every box is worth 10. So that's 70 right there. I let x be 0 and y was 70. Now, what about letting y be 0? Well, then x is 70. I'll do the same thing. 1, 2, 3, 4, 5, 6, 7. And I'll plot the point 70, 0. Now you know what to do. You're going to connect them. Oh, shoot. Try to do it with a straight line as possible. As straight a line as possible. And then it's a less than. So we'll shade underneath it. So we got this little triangle going. Okay. Now we're going to do the other one. Now I might need a little calculator help with the other one. Because look, if I let x be 0, are you paying attention? If I let x be 0, 60y equals 3,000. Oops, you can't see that. If I let x be 0, right here, I'm on this equation. If I let x be 0, 60y equals 3,000, which means y is 3,000 divided by 60, so that's 50. But remember, on my grid, everything is worth 10. So x is 0, y is 50. So 1, 2, 3, 4, it's right here. That's the point, 0, 50. Now, let y be 0. If we let y be 0, then you have the equation 20x equals 3,000. So 3,000 divided by 20 is 150. Now remember, every box is worth 10. So I'm going to have to count out 15 boxes. So there's 7, 8, 9, 10, 11, 12, 13, 14, 15. Right there. So that is the point 150, 0. Guys, you let y be 0, and x turned out to be 150. So that's 150, 0. Okay? So now I'm going to connect my two black dots and shade less than, so below that. And I'm going to end up with this area right here being shaded. This guy right here. Because he's under the red line and under the black line. Notice there are 4 corner points, just like before. So I'm going to write them down. Now, 3 of them are easy. 3 of those corner points are easy. Of course, you've got 0, 0. That's this one right here, 0, 0. This one I already had labeled from before. It's 70, 0. This one I already had labeled from before. It's 0, 50. That's from the original graph. The only one I don't have labeled is the one where they cross again. This isn't there. That's 0, 50. That's this point right here. So I need this one right here. I need this point right here. Now, again, if you have a great graph, you've used a straight edge, everything is fine, you can go ahead and just tell me what that point is. There is no way that I can tell from this mess where that point is. So I am going to take my 2 equations right here, and I'm going to do elimination on them again. So I'm going to eliminate here. I'm going to multiply the top one by negative 20. So negative 20x minus 20y equals negative 1400. The only thing you use the less than for is shading, guys. Otherwise, make it an equals. Do all your math as an equals. And then I have 20x plus 60y equals 3000. So 40y equals, feel free to use a calculator if you need to. It's a negative 1400 and 3000. So that's going to be 16,000. So y equal, or 1600, I'm sorry, 1600. 1,600. So y equals 40. Use a calculator if you need to. Those numbers are kind of big. Now, come back up to this equation right here. If y is 40, then x must be 30. So this point right here on my graph, that one right there, is the point 30, 40. Now I know all of my vertices. My job is to find the maximum profit. Okay? So, what happens if I do no potatoes and no corn? If I do no potatoes and no corn, guess what? I'm going to make no money. What if I do 70 acres of potatoes and no corn? Right down here, put it right in here. So 150 times 70, that's $10,500. Remember, I put 70 in here and 0 in there. Now, put 0 in here and 50 in there. So 50 times 50, $2,500. And then I'm going to put 30 in here and 40 in here. So 150 times 30 plus 50 times 40 adds up to 6,500. Did I do that right? Now, let's answer all the questions on the paper. All right? Write the constraints for the problem. You already did that. The constraints were these equations that you had over here, like x plus y is less than 70. Everything you had written on these lines over here, those were the constraints. The profit equation is right here. You already did that too. This is the profit equation right here. You graphed and found the corner points. You already graphed. These were the corner points. Use your corner points to find the maximum profit. So the answer to D, the maximum profit, is $10,500. That's the answer to question D. What is the optimal solution? In other words, the max profit and the amount of corn and potatoes it takes to get it. So that's when we write our sentence. So to make room, I'm going to erase some of this other stuff now. So the farmer should plant 70 acres of potatoes, and no corn for a profit of $10,500. Yep. Ms. Ford, what happens if I don't write out my answer? Well, you won't get full credit. It's as simple as that. We're going to write out our full answer. We've gone to all that work. It's a huge problem. And there's the answer. All right. Well, that's enough for today. Hope you're doing well. Bye.